ON20, paper 11. We're going to look at a vector drawing. So P and R here are coplanar vectors. So in physics, our vectors are always in 2 dimensions. So P and R are on the same plane, maybe on a table or something. Okay. And it says here, if X is equal to P minus R, okay, what happens when there's a minus? Which diagram best represents the vector X? Okay, chill first, huh? We are going to take X is equal to P minus R. But you see, this minus R, actually, when it comes to vector, we should write something like plus negative R. Meaning it's not like we subtract R because you can't minus a vector, but you can flip the direction. So let's say vector R is now pointing to the right and downwards in this direction. So if I want negative, I will flip the vector over. So I'm going to flip it. And sorry, I need to flip again. Like that. Terbalik. Opposite direction. So if that is R, this will be negative R. Okay, so what do we want again? We want P plus negative R. So remember your arrow should be one after another. So I'll just put P like this. Okay, so then you can just roughly make a sketch on your own paper. Let's say negative R is in this direction. Maybe I'll put P here. Okay. If I do this, then my resultant vector will be, okay, let me move things around a bit first. Okay, I'm back. So your resultant vector would probably be somewhere here. So your X must be in this direction. Of course, some of you may be thinking, Miss, you know, we can draw another slightly different diagram. Yes, we can. So this is one option. Or when I say one after the other, I mean, you could draw a diagram like this. Move your P downwards. Okay. So this is negative R, but this is P. Okay. And your X is in this direction. So this is actually a parallelogram. Okay. So the triangle or the drawing method, triangles are the more common ones, but I'll roughly show you how the parallelogram can look like. But we can now choose a diagram already. Okay. So make sure P and R is aligned. So right now we need X to be pointing slightly at this angle. So this X is totally out already. You look at this weird looking X. So cannot. Okay. So the answer is A. You may be thinking, Miss, their diagram actually look a bit weird, huh? Oh, yeah, look, their diagram does look a bit weird, but I guess it's not really acceptable for you to draw it, but I guess they can. So this one is the best one. Given to you is not the best. All right. So let me show you what I mean by parallelogram in this simulation. Okay, so you see I've roughly sketched out how P and R could look like when I put it inside this simulation. Okay, so a few diagrams that you can draw. The first one that we have drawn is the triangle. So if I click out sum of these two vectors, it will be something like this. So let me check in with X. Oh yeah, there's a negative, my bad. Okay, not sum. You want to flip your R. I was confused a bit. So this is my R. So I'm going to change its direction. So basically, I'm just going to pull this so that it's pointing in this direction. Okay, so R is like this. So if R is pointing in this direction, and this one is pointing here, okay, or maybe you want to draw this one that you see here. R is this one, followed by B. I'm drawing this one now. I am drawing or looking at this one. Okay, right. So if I'm doing that, and this is what I get. So if I want to, okay, let me just make it a little bit more accurate by making this one a bit longer. Okay, not here, tak beberapa. Got it. Okay, like this. So if I want to find the sum, ta-da, the sum will be slightly angled in this direction, like this. Okay. I'm going to keep adjusting a bit so it's a bit more clear. Okay, something like this now. This is your sum. So you can move them and put them together in a triangle that you are used to. Okay, in fact, I'm just going to crop this and put this here for you to see. Ding, ding. Okay, or I guess you could rearrange it so that it looks like the other one, meaning the blue arrow follow one after the other. This one you gotta just try it out yourself, okay? Like that. And then you get this one. Okay, so try it out yourself. But Miss, what taught you about parallelogram? Well, the talk about parallelogram, yes, this one is this one. Talk about parallelogram is like this. Let's say if I go back to this one, let me enlarge this a bit. Okay, so these diagrams are a bit easier to see because it's like you go on the light blue line is equal to going on the dark blue line. But if you're thinking about another drawing that you may see, which is the parallelogram, is to move this one here. Okay, so that both arrows are pointing out, and then you construct a parallelogram. Okay, so you can see if I draw this and this, they will fall into a parallelogram. So it looks a lot like the drawings that you see here. Okay, but the reason why these drawings are not very accurate is because of the direction of X. X has to be pointing in this direction, that side. Okay, so all the X is just a bit off. Okay, but this is also a possible drawing. So I'm going to draw this. So these are all different variations of the very same vector of P minus R. It can be this, it can be this. They're all the same drawing. So in fact, if I stack them like this, okay, I stack them one on top of the other, I will get another parallelogram, so to speak. Okay, so all these also can, but this is for this particular question. So it's probably important that you learn how to draw. Okay, so let me show you where the parallelogram is for those who are a bit cannot see it or not used to it. I'll construct this arrow again. Okay, I push it here. You see, parallelogram is just the two triangles side by side lah. Okay, so this is just a extra for you. So this is the dotted line to build your parallelogram. And of course, I can repeat the same thing for this one right here. Push it up. Bring it here. Hello? Okay, bring this here. Then this is what you will get. This is your parallelogram. It's not conspiracy theory. It's just a combination of these two together. Actually, it should be arranged this way. Ah, yes. Combination of these two vectors like this. Like this. Combine these two, you get this one. Okay? So this is your vector drawing. Learn to draw. If it's negative, remember to flip the sign. Put it all together like a puzzle piece. You will get different variations. Okay? So that's it for this particular question. I'm going to move on to the second vector drawing. Here it says there is a vector R. And then they say which diagram does not represent R as two perpendicular components. Okay, Winter 19 paper 1-3, yeah. Okay, all the components are perpendicular, teacher. Are we stuck? Not really, yeah. Remember the parallelogram? Ah, so the parallelogram is just moving the arrows around. So what I'll do is, if I'm doing this in the exam, I will actually take a ruler, extend this line, try to make it as parallel to the bottom line as possible, extend this line, and then nicely connect the dots in a straight line. Guess I need a line tool for this stuff. I will connect it this way. Okay. Teacher, this one is like, look like the answer. Yeah, it could be, maybe. Okay. Okay. Doesn't mean the rest is wrong. So let us check out the rest. B, because they say not represent. So A represent. A is okay. B. I'm going to do the same thing roughly. So this is all just estimation. And if I were to draw that arrow again, okay, so join the vertex of the parallelogram from where the arrows are pointing out. Okay, so whenever you draw a parallelogram, the vectors are being split. It looks a lot like resolving your vectors. Okay, this one look the same. Yeah, it's like you pull up and then you pull to the right. It's like then you pull in this direction. No? You pull slightly at an angle and this angle, you get this one. No? Oh, teacher, like that also can. Can. I'll repeat. No? Copy paste. Okay, what about you? My friend, and as you can tell, I'm not being very like precise with this, just roughly only. If I need to eliminate some, I mean, unless they're all very close, then that's just my luck. Okay, so this one will be from here to here. This one looks a bit sketch, huh? Because it will be pointing downwards. Don't you think? Pointing downwards, something like this. So this one cannot lor. D, I think okay, but let's just double check. So again, a ruler would be better suited for this, but I don't have one. So I'm going to just use my rough hand to draw. And if I check out this thing, ta-da! That. Okay. I think A, B, and D are roughly all pointing in the same direction. Right? If you look at A, B, and D. So which one is not possible? C lor, because C is at this weird angling down. Nani? That does not represent. Okay? Because R is like this. See? R is pointing out. Okay? So this is an example of using the parallelogram method. Or if you don't want a parallelogram, it's okay to just copy this arrow. Copy this arrow and move it here, which is essentially drawing a parallelogram line. It's the same picture, okay? Don't need to extra. All right. So this is the objective question of using the parallelogram. Next one, from Summer 19 Paper 11. A particle has velocity v at an angle theta to the horizontal. Okay, now draw nicely for you already. Very good. The component of the particle's velocity is vv and vh. So vv is upward in the vertical direction. Okay, sorry, that was lag. vv is upward in the vertical direction. And vh is right in the horizontal direction. Oh, they draw for us that. Very nice. Which are the expressions for the magnitude of v and the magnitude of theta? Well, I didn't talk about this when we resolve vectors because I just want to keep the video not too long. But you know that the parallelogram idea? So it's a little bit like you have this v in the middle, right? This v is here. And you're going to split it into two. Resolve. Split. Okay, so when you split, it's the same as you go from VH followed by VV. And this is theta. So I guess if you want to find V, because of this nice right angle triangle here, V will be VH squared plus VV squared. You know my good friend Pythagoras? Okay. And if you want to find theta, you can use tangent theta is equal to opposite, which is VV. Okay, theta is here. This is opposite. Okay, over the adjacent. So kato. Okay, so opposite over adjacent. So theta will be, you bring the tangent over, is tangent inverse VV over VH. Bonus. So what is this minus? This is wrong. Okay, and tangent inverse opposite over adjacent. So opposite to theta is VV. VV here. Okay, so that's the answer. Circle with a different color. All right, it's pretty straightforward one. This is actually resolving vector. So think about this. VV and VH can become V, can combine. So I'll write here for you. the vector VV plus the vector VH is equal to the vector V. And it's a two-way arrow. You can combine them using Pythagoras. You can also resolve them using the right angle triangle, which was what we have done in the lecture video. Okay, so very similar to this splitting into two. You don't really need to, there are many ways to split. Can split like this, can split like this, can split like this. Teacher, how I know which one is correct? Depends on the question drawn for you. We'll try more examples about that later. Okay, let's look at another objective question. This is from Winter 20 Paper 1-2. So here, it says a diagram shows a force F. P is the horizontal component of F and at an angle theta to F. Okay. So P is part of F. It says here, P is the horizontal component of F. Okay, meaning this is F, and then you split F into two. We resolve. One is pointing up, one is pointing to the left, and this is theta, and this thing is P. So P, because it's right beside the angle, is actually F adjacent cos theta. So you tell me, how does a cos theta graph look like from 0 to 90? Okay, so cos theta, teacher, I remember my trigo. Cos theta look like this. Can, but we just want 90 degrees, so 90 degrees is here. So look at the graph, the only one is A. Teacher, I don't remember cos theta leh. Other method got got. Now, you can check. If theta is 0, then your force is going to be flat like that. Right? This F is going to fall flat. Fall flat, theta 0. So if it falls flat, then what happened to your force? Your force is maximum, right? F is equal to P. Okay? If theta is 90 degrees, that means your F is like that. Is there any horizontal component? Can split? Cannot. When you reach 90 degrees, you hit 0 now. F equal to 0. Because F looks like, or rather, sorry, P equal to 0. Because F looks like this. That's why P equal to 0. Because your P is in this direction. So when theta is equal to 0, everybody follow this direction. When theta is 90, nobody follow this direction. Sadness. So that's why this is 0. Okay? Let me show you another visual for this. Okay, here, good old vector. All right. So you can see, right, this full arrow, can I move this a bit? Put here. This full arrow is your F. This horizontal dotted arrow, horizontal one, this one is your P. We want to draw P, the horizontal one, with respect to theta. I show you theta. Theta is here. Okay. So if I make this shorter and shorter, so theta is shorter and shorter, you can see the vertical component don't have, so you only have horizontal component. This is maximum. 17. Okay. So let's say I try my best to maintain 17, although it's kind of hard in this courseware. And then if I move up, you notice the horizontal arrow becomes shorter, even though I try to keep it at around 17. You see how small this one is? Because as you go more and more upwards, your parallelogram becomes thinner because you're splitting it into two. So by the time you reach here, 0 level, no more. See? Vx is 0. Okay? So you increase the angle, this one will be longer. Decrease the angle, it will be shorter. Okay? So please know how to interpret this. And of course, if you're good in maths, it's never going to hurt your physics to be good in maths. Okay? So that's it for this question. All right, one more or a few more. Here, there are two forces, 10 Newton and 10 Newton, and they act on a point P as shown. So one is pulling at this angle. They draw for you already. One is in this direction. So again, the whole problem of vector not being parallel. What is the magnitude of the resultant force? Okay, so it is at this point in time where you should know that there are a few choices. You can either use solution of triangles, draw a triangle, or you can try to resolve. So since resolve is a slightly more important skill, I will use the resolving method. Okay, so let's see. I'm not going to resolve the 10 because I like horizontal components. I'm going to stick this here. This 10 I keep. This other 10 there, so naughty one. Why is it 180 degree away from your friend? Okay, never mind. I split into 2. So this 10 Newton, I'm going to split this. One is like this, okay? Because it's pointing upwards. And one is like this, it's pointing here. Teacher, which angle to use? Up to you lah. You want to use this one 60? Can. You want to use this 130? Also can, as long as you know when to sine and when to cos. So I am going to stick to 60, okay? Just because I can. All right, so this is right beside 60, adjacent to 60. So because it's adjacent to 60, this will be 10 cos 60. I know 10 cos 60 is 5. Okay, this one, 10 sine 60. 10 sine 60 is 8.66, I think. 67. Anyway, let's try. 60 times 10. 8.66. Wow, miss, how you know? Do too many these kind of general angles already. Root 3 over 2. That is sine 60. Okay. Wait. So step 1. What did we do? We resolve or split. We call it the formal term is resolve, but you can say split into x and y direction. Done. Okay, step 2. Find the sum of x. Find the sum of y. Okay, so I'm going to do step 2 now. Sum in the horizontal direction, x, you want to put h also can lah. I like x. Okay, so it'll be 10 minus 5, which is 5 Newton. Miss, why minus? You see this opposite direction. Negative. Okay, so put negative 5 here. Sum of Fy is the lonely 8.66. How miss? Nobody, no. Just lone. Just read it. Okay. All right, then step 3. Combine Fx and Fy. Okay. Step 3. Fx is 5 Newton to the right because positive 5. Fy is 8.66 Newton upwards because there's only one vertical component in play. So where's the resultant? Ladies and gentlemen, boys and girls, the resultant is here. Call it Fr for resultant force. So how do we find resultant force? Fr will be equal to 5 squared plus 8.66 squared. Okay, then you can find the resultant force. Okay, let me ask my calculator. So those of you who do maths or further maths, you chill first. Physics, we don't really emphasize on the actual numbers. It's okay to be a little bit off. It's fine. Okay, so I got 10 Newton or 8.9999. So this is 10. All right. This method is like a universal method. No matter what question, confirm can do. But those of you who are actually pretty good at geometry, you will notice that, miss, you took so many steps, it's not needed. Got shortcut one. But whether you can see a shortcut or not is up to your student, I guess. Okay, so let me copy this picture again and show you the shortcut. Resolve vector, confirm can do. Got shortcut, this one? God. I see same length, Ayo, my heart will skip a beat one. Because I think isosceles triangle, even better. Equilateral. Okay, let me check other kata got or not. Okay. Put here. Okay. Hey, 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 hey. Where's the resultant? This is 10 Newton. I move it a bit so that I'm not looking at the parallelogram anymore. This is my other force. Okay, so this is also 10 Newton. And your resultant will be here. Ding, ding. This one is also 10 lah. This is resultant, FR. Teacher, how you know? Man, this one is 60 ma, right? And this one same length. So if these two same length, then this one 60, this one also 60 lor, because it's 120 divided by 2. Equilateral triangle. So everybody is a 10. You are a 10 too, my friend, for doing the work of learning your physics. Okay? Yep, so shortcut lah, but if you cannot see, then don't worry, guys. It's okay. This one, any angle, any direction, confirm can do. Just a bit long, because you need to split. Basically, split, sum, combine. Split, sum, combine. Okay, so that's it for this question. And here is the last interesting one. This one is May, June 17, paper 1-2. Two forces act on a circular disc as shown. Okay, sure, that's 3 and 4, and I'm happy. Which diagram shows the line of action of the resultant force? So some of you is like, Miss, I know. No, you go like that, or you go like that, 3 Newton. Going up, this 3 Newton. Okay, and then you see this 4 Newton, teacher. This 4 Newton going to the right. Okay, I know already. I smart liao. This one is 4. I draw a bit longer. Okay, fine. So where's the resultant, guys? Well, the resultant will be here. I mean, I know it's going to be 5. So I'm like, we look for 5, pointing in the outward direction. GG. Everything is pointing 5 Newton to the outward direction. There you go, like. Question, why you do me like this? Well, objectives can be quite hard because sometimes they need to test and see whether you know what's going on. Okay, so one by one. See, I pull 3 Newton here, and then I pull 4 Newton here. So if I look at the line of where the force is acting, it should be along this line, because 3 Newton is here, 4 Newton is here. This is the point joining both dots. So immediately I will eliminate D. This is out. Because if I pull here and here, it cannot be equivalent to me pulling like that, right? That makes no sense. Why, how is there a sudden force in this direction? What, how, what? No, cannot. Okay, so it cannot be, it has to be on the line of force. So I'll write here why cannot. Not on the line of force. Okay. Then you think to yourself, well, teacher, B also very sus leh, for the same reason, right? Because 4 is acting horizontally. So 4 must be on the line of force here. Nani? What is going on? So this is not on the horizontal line of force. So now you got A and C, and GG lor. The force, the resultant is here. It must be acting in this direction. Teacher, which one lah? Well, then I gotta ask you. If you were to draw a horizontal line, I'm going to draw a rough one, okay? You can draw a better one. You will notice that the only difference between A and C is this angle. Sometimes the angle here tiny, and this angle here a little bit bigger. So I guess my question to you is, do you think that this angle here will be smaller or bigger than 45? If you look at this 3 and this 4, the angle is only going to be 45 if it's an isosceles triangle. Remember? Because this one is 90 degree ma. This is 90. So this BB is not going to be 45, man. Unless they are isosceles, which they are not. Okay. So this angle here, this orange angle, Because when you draw, no need to think so much one. The 3 Newton rises less compared to horizontal. So the answer is A, because the horizontal 3 Newton, horizontal 4 Newton is greater than the vertical 3 Newton. So the rise or the angle, what's going to call this, theta. So because of this, theta is less high lah, but less than 45. So if I look at C, C looks like 45. In fact, the examiner report say candidates are encouraged to draw on their question paper. Okay, lor? Next time you draw 3 smaller than 4. Okay, so because 3 is smaller than 4, this orange angle, this theta here, is going to be less than 45 degrees. Like I said, if you know your maths, it's not going to hurt you. If you don't know, it's not too late to catch up. Okay, so go try out some vector question, draw some arrows, draw some diagram, take out a ruler and protractor, resolve all the vectors, and I will see you in the next video. Be smarter. Bye-bye.